Hello, welcome to DSP's presentation on taking SQL Server 2012 into the cloud. My name is Mark Jones and I'm a Senior Architect for DSP in the data platform for SQL Server. I've included my email address as you can see, so please feel free to email me if you have any questions on the content of this presentation or if you have any feedback in general. One of the things DSP is seeing at the moment from our clients is a big push towards a cloud adoption program. And two kind of key questions come out of that. First of all, when I consider the data platform and my SQL Server, which cloud paradigm is right for me? Is it a public cloud, is it a private cloud, or is it a hybrid combination of the two? Secondly, if I'm buying SQL Server 2012 and I'm making that investment now, how does that really help me? How does it push forward my cloud adoption program? So to try and answer some of these questions, we're going to start looking at some of the trends within the market to see what other people are doing with their cloud adoption and how we can start to learn those lessons to push forward a data platform cloud adoption program. We're also going to look at some of the age-old challenges around databases to see if there are new ways of working which can overcome these. We'll start to look at SQL Server 2012 specifically and see what comes out of the box with SQL Server that can help you drive your adoption into a cloud platform. And finally, we'll just have a summary of the items we discussed today, look at some of the things that DSP have been doing with our clients, as well as some actions to take forward. So, current trends within the industry. At the moment, we are seeing a massive upturn in the adoption of cloud platforms. It's been around for some time now, but certainly in the last 3 to 4 months, the velocity of customers talking and adopting cloud platforms has really increased. One of the things that we see at DSP is hybrid cloud as probably the easiest way and the most efficient way to start adopting a cloud platform. Higher value transactions are starting to go through cloud platforms, and certainly the uptake is really starting to gain momentum. And this is big news for databases. The data platform is one of the key hubs of your enterprise, is the go-to place for all of your data consumers, whether they be users, applications or reporting. So if the rest of our environments or the rest of our enterprise is moving towards a cloud strategy, we need to start really thinking about how our database tiers are going to move with them. So a key question to ask is, why is cloud doing things differently? And before we start to answer that, I think it's important that we start to take a step backwards to consider what has been happening within the industry for the last 15 to 20 years and how we can start to move forward, learn from some of the mistakes we've made up until now. So let's look at the infrastructure evolution. In the past, we've had our infrastructure was purely controlled by the IT department, and if we go back 15-20 years, our data center looked very different to as it did today. We had one application to a server. It was very siloed, but it did work. Then came along virtualization, which was a massive shift in the way the data center was structured. We suddenly realized that we could have a single server, a single piece of tin that could have many different services and servers on there, consolidating resources and saving a lot of time, saving a lot of money. There were a lot of mistakes made with virtualization in those early days. Workloads that weren't suited for virtualization were kind of crammed into those servers and they really struggled. Secondly, I think a lot of companies invested a large amount of money in virtualization as a kind of snapshot view of what they had now, and they didn't start to plan about what virtualization meant further down the road. Budgets dried up and servers kept getting workloads pushed onto them when they were already fully utilized, because that investment had dried up. So I think there are some lessons to be learned from that. When we move forward into our cloud platform, we want to use the right tools for the problem that we have in front of us, and if that isn't the right tool, we need to go back into the toolbar to solve the issue. And then cloud has come along, and we view this as virtualization grown up. It brings together all of the things that virtualization has done, so the consolidation of resources, the resource pooling, but it's also added a couple of key features on top of that that businesses and organizations are starting to want. The set and forget provisioning, creating golden images, so you spend your time creating the perfect server environment for your estate once, and then you just keep using that again and again. We don't want to spend our time installing servers and services. We just want to be clicking a button and those services be self-provisioning. Secondly, we have the self-service. Me as a business user or business consumer, I no longer have to interface with IT, or my products and services can have this infrastructure they need quickly and effectively through the IT slot machine. So I can go to a self-service portal and I quickly and effectively spin up my own instances, and I am working quickly and effectively. Lastly, elasticity. A key component in new greenfield applications, or if I'm starting a new service and I'm unsure of the demand, this elastic capability is really a key feature for business users. It reduces risk to the business. So one of the key questions we always ask ourselves at DSP is, if I was to start the next Facebook, would I be doing that today by using the traditional model of buying a data center or having data center space, hiring the right people, and then installing servers? I probably wouldn't be doing that. I would start to look at using cloud-based technologies, because I don't want to worry about those things. I don't need to worry about IT anymore. I want to start worrying about my business and not worrying about the technical issues. So when I'm considering this decision of what kind of platform I want to be moving to, I have a few choices in front of me. Public cloud is obviously one of the key first considerations I should start to look at. With public cloud, I can pay as I go. So if I am uncertain of my demand of my application and my service, I can just spin up the minimal amount of servers that I need and I will just pay for them. As my service and application starts to take off, my new Facebook starts to get popular, I can grow into that, which leads on to kind of the flexibility and scalability. I don't need the expertise of good infrastructure people. They're very hard to find and very hard to hold on to. Good people are hard to find. So I don't need to worry about that kind of recruitment anymore. With the scalability, I have really at my disposal unlimited scalability for my application. So as a business owner, I don't worry about having floor space and data centers, etc. My public cloud provider will worry about that for me. With a private cloud, if I have specific requirements that mean my data needs to be controlled, if I have data sovereignty issues or governance or legislation from governments, etc., I can make use of private cloud, which means I can have all of this resource pooling, but I'm going to build my cloud environment myself within my own controlled data center. So I know exactly where my data is, and I know I am compliant with all of the latest legislation. I still retain the self-service IT, so I still got my IT slot machine that my business users and business consumers can go to and self-service provision. Yes, I have complete control over my estate. I know exactly where my data is, and I know when and how people are accessing that. Lastly, we have a combination of the two, which is kind of the best of both worlds, and like I said before, is one of the quickest ways DSP are seeing adoption of cloud strategies for the data platform. You keep control where you need it, so if you are a government organization or you have compliance around data security, you can keep that part of your data in your private database cloud in your data center, and you know exactly where that data is, and you keep that sovereignty. But you have the ability then to have a public cloud, and you could burst into that to keep the kind of scalability. So if you have a OLTP and a database reporting, you could set the OLTP side into the public cloud, burst into there, and you've got all of the elastic capability. With a hybrid cloud, you also have your quick time to market. So the self-service provisioning, your IT slot machine is still there, whether it's in the public cloud or private cloud. And a lot of the latest and greatest from Microsoft, including SQL Server 2012, System Center 2012, and Windows 2012, is all about the hybrid cloud. It's all about quickly and effectively monitoring and provisioning your services within both markets, and you've got a single pane of glass to manage the two. So we see the cloud as a massive push to the future, and of the three paradigms, we see the hybrid cloud as being probably the way to start adopting a cloud strategy. For a number of reasons. You don't have to, completely throw away all of the investment that you've already got. You make use of that investment, but you're also starting to use some of the latest and greatest from Microsoft. So why is cloud doing things differently? Well, for the first time, we at DSP see the business users and business consumers within an organization are starting to dictate the demographic of the IT infrastructure. If you go back 15, 20 years, maybe even 5 years, IT had complete control what went into the data center. But what cloud is now doing is it's bringing IT and the business closer together. And businesses are now starting to make decisions about exactly what products and services they want to take to market, how quickly they want to take those to market, and the solution that will provide those. When businesses and IT do work together, we find it does deliver really robust solutions. This is why we feel this is a bit of a soft benefit, but it's one of the key benefits. It's bringing businesses and IT together to unify their solution for new products and services. So what does this mean for database clouds? So what do database private clouds offer? Well, we get all of the resource pooling, the self-service IT, and the elastic capability. That is fantastic. But what does this mean for the databases? So databases are just not universal. They don't all do the same thing. They have different types of workloads. So one of the key important things that we need to consider when we look at a private cloud is choosing the right solution for the type of workload that we're doing. So my database platform could be mostly OLTP based. So I'm going to pick a solution for my private cloud. My private cloud solution is going to be OLTP focused. If it's a data warehouse or decision making application, I can pick the right solution for that. Secondly, I retain my data sovereignty. So my private cloud is on premise. I know where my data is. I know how it's being controlled. My latency is also reduced. So if I'm using a public cloud, I have to go out to the internet or through VPN to my cloud provider. Now I may not have really great pipes out to the internet. So what I need to do is to control that flow of data over that long wire, and keeping my databases near my consumers, and if they're all on site as well, means I have that reduced latency and my users are having an enhanced experience. Obviously, it's important to consider costs as well with my private clouds. So with private clouds, you're kind of buying your investment up front, especially when we're considering appliances, which we'll talk about further on. So the OPEX will be vastly reduced because I'm not paying month on month, but I will have a big CapEx investment. But that may suit the budget that I have. Well, public clouds, you've got a number of public cloud offerings at the moment out in the industry. So Microsoft Azure would be one. Amazon is obviously a big player. We at DSP use SunGuard. There are a lot of providers out there. And one of the things they immediately offer is being geographically dispersed. So I can have my database replicated to a number of geolocations. I don't need any infrastructure expertise. I don't need to have those, fantastic people who make all of these things work. I just let my cloud partner worry about that. I do have to worry about latency though. So if my consumers of my database are in cloud and also on premise, I need to think about my infrastructure in between my public cloud and my consumers, because my database needs to really be near my data consumers. With the costs, if I'm only going to go public cloud, I don't need a capex investment. So if that's the type of budget you're looking at, really public cloud may make a lot of sense for you. Lastly, we have the hybrid cloud, which brings together both the public and the private cloud solutions into a tailor-made custom solution. The key reason why this is by far and away the fastest cloud adoption methodology. We see it being suitable for when demand starts to outpace a solution. So if I've got an on-premise solution that's starting to reach the end of life, or my demand for this product or service that's being hosted by this infrastructure is growing too fast, we can move into the public cloud and burst into that. Obviously, cloud bursting is a key feature of hybrid cloud. So being able to have a private cloud solution that once I start to grow, I can burst into the public cloud. But obviously, we need to think about what data exactly, what applications we can move into the public cloud, so we retain that data security within the public domain. There is obviously, the more we burst into the cloud, there will be an OPEX increased, and the latency of the consumer is also a consideration. Obviously, all the major vendors at the moment provide secure communications, but it is worth checking to make sure that our databases and our data movement is being secured. So that's the current database trends. Let's move on to see what are some of the key challenges with databases and what we need to think when we start to consider a cloud platform. So firstly, database scalability is a challenge. And what do I mean by that? Well, if we consider this standard diagram, this is probably reflecting quite a number of applications out there in the market at the moment. And if I just bring the mouse in a little bit, we have a traditional methodology for our applications. The constituent parts of this include a presentation tier, a middleware tier, and a database tier. And what we can do with the presentation and the middleware tiers is effectively they can have a load balancer in front of them, or many load balancers. It can have as many as you like, but we are able to direct traffic to individual servers and effectively scale out this solution by adding more servers. With the database tier, we can't do that traditionally. We don't have a load balancer in front of it, and so what happens is this master database, or the database server that is the go-to area, falls behind the rest of these two tiers. So as an application becomes more and more popular, as the application demographic grows, we could scale these presentation and middleware tiers outwards. We can put geographical locations on these, etc. But with the database, we are stuck with just a single version of the truth and this go-to area. Obviously, with SQL Server 2012, we have always on availability, which means we can have up to 4 of these which can be read. So we can have this master, and we can also use the multiple slaves that we have, up to 4 of them, as readable subscribers. But we are still constrained by 4, so we can't grow this database tier outwards like we do with the middleware and presentation tiers. So while with the application layers it is easy to scale, the databases are not so easy to scale. And the reason is because the database is your persistent data platform. It's where all of our transactions go to, and we know they are committed. So if I'm selling a car and that has been saved to the database, I know that transaction's held within there. I don't want to worry about has the car been sold and we've suddenly lost the database. I'm not suddenly sure if that transaction has reached it. Secondly, key rules of databases, and this is probably true of all databases, no matter how well written they are or how performant they are. A database with the small amount of records would be quite quick, whereas a database with, or a table with a large amount of records, millions and millions of rows, will be quite slow. So one of the key things we want to do, especially when we start to look at public clouds, is to keep our databases small. And this affects the whole platform really, from maintenance to backups, etc. If we have large databases, everything takes a lot longer. We want to try and keep our databases small. And one of the key things that I get asked is, well, if I consider, say, Microsoft Azure, why is there only a 50 gig maximum on databases, which is soon to be upgraded in version 2 of Azure to 150 gig? Why is that so small? Well, it starts to force you to follow this key rule, and it's a good thing. We don't want a big monolithic database. We want many small databases, and that's one of the key ways we can start to manage our data platform more effectively moving forward. So scaling database tiers. Well, sharding is one of the ways we could do this. Sharding is a term that's come out since MongoDB or NoSQL. It really is just a new way of partitioning data and storing that partition data into separate databases. Certainly within the public domain, there is a new fantastic way within Microsoft Azure to support sharding technologies. They do work slightly differently to the old ACID convention. And it really is around the consistency. So ACID, we know the transaction, as soon as it's been received, it has been written to the database. With a base methodology, which is what MongoDB and NoSQL start to use, it has this eventual consistency rule. So we know when we sell a car that the transaction then goes into a queue and eventually will be received by the database and stored. But what we need to think about during a disaster is how do we true up those queues to ensure that those transactions are getting through. So here we just have a high-level overview of 3 application servers in green, and we have 4 SQL servers in red. And the application servers are partitioned along with the database layer based on the customer ID number. So a update to an application server here could be talking to customer ID 1, that would go to SQL Server 1. Equally, if this application server wanted to get information across from customers 2 and 3, it would be pulling data from SQL Server 2 and SQL Server 3. That's just a high-level overview of what we can start to do with partitioning and sharding. Next, we'll look at how SQL Server 2012 specifically starts to help us drive an adoption program using some of the features that come out of the box. So firstly, database scaling. As we've been talking about in the previous slides, we need to start thinking about how our database layer can scale along with our application and middleware layers. So with a private cloud, if we start to think about using a private cloud for a base methodology, we can start to use the features like Service Broker, which provides async messaging to develop a scale-out solution for our database. We also have distributed queries, which is a new feature in SQL Server 2012, which allows us to query across multiple database servers. Also, we've already mentioned, we have Always On, which allows us to have up to 4 readable subscriptions. So we can have a master database with up to 4 copies of that data, and we can read that data for our queries, but it is read-only. Secondly, we have a public cloud, and a new feature within SQL Azure specifically is federations. And this is a fantastic new feature which allows proper sharding of our data platform. It supports split and drop partitioning. So basically behind the scenes, this is a partition feature, but it has a number of layers on top which allows us to manage and consume that data. It doesn't support the merge technology, which doesn't give us true elasticity. Certainly we can start to scale out, but if we need to scale back our data platform, because it doesn't support merge at the moment, but this feature is coming with the next version of SQL Azure, we don't get true elasticity. It does become a bit of a convoluted effort to start to merge partitions, but not impossible, but certainly a lot more tricky. The splitting and drop of partitions is non-blocking, so our transactions happily still work away while we start growing our federation. and I will say it's very easy to use, and it starts to allow this scale out database tier, which is now in tune with the middleware tiers and the presentation layers, which we could say a presentation layer talks to a middleware layer, and that talks to a specific SQL Server within our federation, which has been tuned for that, say, regional or geographical data. Here's just a quick snapshot of a SQL Server federation within Azure. This federation has 50 members, as you can see, and at the bottom here we can see all 50 members, and we can see on a kind of heat map how each of those partitions within our federation are growing. And here we see we've got a bit of a problem because one's gone a bit red. That's because this federation has started to fill up. Within the console, you've got the ability to quickly and effectively grow that resize that partition and grow it to a more suitable level. So you can see, at a single pane of glass, how quickly and effectively your federation is working, how your partitions are being populated, and it is really easy to use. I've been really impressed with this feature for SQL Server. And it's all based on SQL Server 2012 technologies. Secondly, we have licensing. Now, whether we are using a public or private cloud, we need SQL Server licenses to use the product. With the introduction of SQL Server 2012, we have moved from a physical processor license model to a core-based model. That was one of the things that was introduced with SQL Server 2012. When we used to buy SQL Server licenses, we used to buy the physical processor. If you didn't buy those with software assurance, the SQL Server license would actually be sticky. And what do I mean by that? Well, by sticky, what I mean is if I run SQL Server and I've licensed it on server A, I can't move it off server A until after 90 days. So that doesn't really lend itself towards a public or private cloud where we need license mobility. Also, when we consider public and private cloud, we want unlimited amount of SQL servers to be at our disposal. With SQL Server 2012, you can do this by licensing all of the processors on the box. So this allows you then to have as many SQL servers as you'd like on that environment, but also you have the flexibility of licensing just the individual virtual machines as well, because this is now a core-based licensing. So it is a lot more flexible than the old processor license where you weren't able to do that. The costs, obviously, we need to consider as well. With the old physical processor model, we weren't worried about the number of cores in there. The core-based licenses are a lot cheaper than the old physical licenses. You do need a minimum of 4 per VM, and 4 cores is about the same price as an old physical processor. Thirdly, integration. When we are using Microsoft's solution, if you have Microsoft applications in your stack, such as SharePoint, or you're using .NET to develop your applications, you certainly should start to look at using Microsoft's backend. I don't know of another vendor that offers end-to-end everything you need to build yourself a hybrid cloud. And the integration between all of these systems is absolutely fantastic. With System Center 2012, you get the ability to manage your Azure environment as well as your own on-private Hyper-V environment and flip workloads in between the two seamlessly. With SQL Server 2012, you get the Management Studio, which allows you to register your databases within a public or private cloud and manage those exactly the same way. So it really is unparalleled integration. I don't know of another provider, another vendor that can do this end-to-end solution stack. So hybrid cloud. So one of the key considerations when we build a hybrid cloud is how do we synchronize our data between what's on premise and what's in the public space. And certainly with SQL Server Azure 2012, we have a new feature called Data Sync. Now, DataSync is a full merge replication service with conflict engines, etc. that's bidirectional, and you can install it on your private cloud tier. So there's a little widget that gets installed on your private cloud that synchronizes your databases with the public cloud. You manage the application through Azure. It's very simple, very quick and effective, and it allows you to have many different paradigms. You can replicate from cloud to cloud, premise to cloud, and vice versa. And it does start to open some new paradigms of tackling some major problems within a hybrid cloud solution. And I've got 3 here for you to see. So if I just bring the mouse in, here we have a head office which has a SQL Server with an application. It also has a database which is then replicated in one direction through Azure DataSync to a Azure public cloud. There is also a DR application which is enabled in a disaster recovery scenario. So if we lost our head office, we have up to the last 5 minutes of data within this slave, and that can be turned on, and the DR application can start talking to that, and we are back up and working quickly and effectively. Secondly, a more complicated solution but equally just as effective. Here we have our head office again, and here we have an Office application that talks to a SQL Server, and here we have our master data. So this is the database that contains all of the information for our entire enterprise. This is then synchronized through Azure DataSync in a bidirectional manner to a database hub. So really this is just a copy of what is in the master database here. The database within the cloud can then replicate individual regional data to a regional office, and you can scale out this solution by having n number of regional offices. So basically the database hub becomes a replication hub. Data that's changed in the regional offices gets sent back to the database hub and then resent back down to the master databases. So we have all of our data that's kept in sync. And again, if any data here changes that affects the regional office, that will replicate up to the hub and then replicate back down to our regional office. Like I said, you can have as many regional offices as you like, and it is one of the ways you could start to scale out your data platform. Very, very cool feature. And lastly, we've got cloud bursting. Here we have an application again that talks to a SQL Server, and here we have 2 master databases, so they're fully in sync with each other. During certain times of the year, I can start using an OLTP application within the cloud. One of the scenarios that we at DSP are looking at is our client deals with student bookings. And so for 51 weeks of the year, student bookings are fairly stagnant. But for 1 week of the year where everyone gets their A-level results, that's extremely busy. What we don't want to do is build a massive SQL Server environment here, which is going to cost a lot of licenses. It's going to be very expensive to run to meet that demand for 1 week of the year. What we want to try and do is leverage the power of a public cloud where we pay as we go for that 1 week a year, so it's not so expensive. In that situation, we have used Azure DataSync to synchronize a SQL Server 2012 environment with Azure, and the application is flipped from within the office to within the cloud for this 1 week a year. After that 1 week, the application is flipped back to the office and things resume as normal. This really is a powerful feature and does really save quite a lot of money. So lastly, we have private clouds. So Microsoft has been collaborating with HP to bring to market a number of solutions called appliances, which are specific to different types of applications. These include the data warehouse, which has up to 16 terabytes per second throughput for crunching through data. The consolidation appliance, which can consolidate up to 200 SQL Server workloads. And the decision-making appliance, which has everything you need: SharePoint, Power Pivot, and SQL Server 2012 in a wizard-driven installation that takes under an hour. The only thing you need to do is to drop them into your data center, plug in the network, plug in the power, and run through the wizard to configure that environment. And there are a number of videos online that have all 3 solutions up and working within an hour. And if we start looking at the consolidation appliance here, it is commodity hardware, so standard HP hardware, but we're configured and installed in such a way that they are completely balanced. So the number of servers, the number of CPUs, the amount of RAM, and the amount of IOPS and spindles is balanced in such a way that there is no hotspot within this environment. With this consolidation appliance with a full rack, it can consolidate 200 SQL Server workloads onto 8 servers. It's a massive consolidation ratio, and obviously as a Microsoft solution stack, it's Hyper-V, System Center, etc. in the back end. So hopefully that's given you a brief overview of some of the top ways SQL Server 2012 can help you drive your cloud adoption program for your database tiers. So in summary, some of the things the DSP are doing with SQL Server 2012 that we're quite excited to talk about include database modernization projects, which include private and public cloud solutions as part of that. We're getting massive consolidation ratios, so if we look at the appliances, we can save up to 80% on hardware, which is a return on investment that is massive. We also are introducing an aligned platform. We try to make everything SQL Server 2012. If we got an existing SQL Server 2005 or 2008 estate, we can align that platform to SQL Server 2012 quickly and effectively, which really does lower the total cost of ownership. If we do have applications that need to have SQL Server in a legacy platform, well, we're using cloud methodology. We can run those in legacy quite easily. We're delivering solutions obviously based on this cloud platform that scale to business needs. It really is a fantastic new way of working with SQL Server. Secondly, we are using the hybrid cloud bursting solution, as I mentioned, with our client who does student bookings, and also we are doing database upgrades as bog standard. What we will say with database upgrades to SQL Server 2012 is they are really quick and really easy. And one of the other things that DSP are doing is we help you realize your investment. So we look at SQL Server 2012 as an entire solution. We don't just try and put it in to fix one problem. While we're doing that, we say, well, what other features does SQL Server 2012 come with? Compression, partitioning, business intelligence. How can we turn those on and start saving you money? Lastly, we have our managed services. So DSP were a launch partner for SQL Server 2012. So we've been using this technology since September of last year. We have a number of clients on SQL Server 2012 and also have hybrid cloud solutions. And we manage their solution end to end. So we look at the database here, we're looking at the cloud solution, and we manage that for them, even down to working out how much they're going to be billed month on month. So how does SQL Server 2012 enable your journey to the cloud? Well, it offers you cloud scalability, new paradigms for working, meets the demands of your business, and helps save you money. And we really think in 2 words, that opens the opportunity for you. So SQL Server 2012 investment is one that will help you realize your cloud platform. I'd just like to thank you for your time today. My name's Mark Jones, and this has been Taking SQL Server 2012 into the Cloud.